CTk Enter is a Python library that can be used to construct basic graphical user interface applications. But as you can see in this example, visually the GUI looks quite unspectacular. However, you can easily improve the appearance of the GUI application using Customtk Enter. Customtk Enter is a CTk Enter extension which provides new, modern, and fully customizable widgets. This video walks through each Customtk Enter widget and gives you a quick overview of the widget's customizable options. To install the library, use this command: pip install Customtk Enter. Let's start with the main window. Create the main app window by initializing a CTk class object. You can configure the width and height and set a window title. Calling the main loop starts the application. The appearance of the window can be modified. You can choose between light mode and dark mode. If you don't set an appearance mode, the appearance mode defaults to system. In this case, the appearance of the main window depends on the color settings of your desktop. This means that if the color setting is set to light or dark, the window will appear in light mode or dark mode respectively. It is also possible to change the color within the window. You can either use the color name or the hex code of the color. Button. If you need a button, create a CTk Button class object and provide the main window object as first parameter. Choose a button name and use the grid function to set the button's position in the main window. Use the parameter command to set a function that will be executed if the button is pressed. In this example, I created a function that changes the hover color of the button to a random color of the list. The color changes every time the button is pressed. You have also the option to change the width and height of the button. You can also customize the text color of the button color, and the hover color. If you want your button to have a border, you can add it by setting a border width. The border color is gray by default, but you can change it if necessary. If you don't want a rectangular button, you can set a corner radius, which creates a button with round corners. There is also the option to add an icon to the button. For that purpose, you need first to import the class image from PIL. Then create an CTk image object with an image of your choice and provide it to your button widget. The image will appear as icon on the left side of the button name. If you want to modify the position of the icon, just use the parameter compound and set your desired position. In addition to the left position, you can also place the icon on the right, top, and bottom. RadioButton. You can create a radio button by using the CTk RadioButton class. Provide the main window and a text as parameters. A RadioButton widget will appear in your application. The RadioButton widget requires a variable to control or read the checkbox state. For that purpose, it is recommended to create a Customtkinter variable and use it for the variable parameter. The initial value of the variable is 0. You also need to provide a value for the radio button. When the radio button is pressed, the variable takes on this value. You can also link the radio button to a function that is executed when the radio button is pressed. Use the command parameter for this. Let's create 2 additional radio buttons. We set their value parameters to the values 2 and 3. Because all the radio buttons have the same variable, only one of them can be activated. The value of the Customtkinter variable changes to the value of the radio button. If you change the initial value of the Customtkinter variable, for example to 2, the checkbox state of the second radio button is activated by default. When the radio buttons are pressed, the command function is executed and prints the value of the Customtkinter variable. As you can see, the value of the variable changes to that value which was given in the value parameter of the radio button. There are many options to customize the widget. For example, you can change the text color. The foreground color of the radio button can also be changed. If you want to change the color of the unchecked radio button, you can use the border color parameter. It is also possible to change the hover color of the radio button. Simply use the hover color parameter. If you want to deactivate the hover effect, set the hover parameter to false. Then the color does not change when you hover over the radio button. Another property you can change is the border width of the unchecked radio button. Similarly, you can also change the border width of the checked radio button. You can also modify the size. Use the radio button width parameter to change the width. A value of 50 results in a wide-shaped radio button. The height can be changed in the same way. If you want a square-shaped radio button, you can set the corner_radius parameter to 1. Checkbox. The CTk CheckBox class can be used to create a checkbox widget. Use the main window as a parameter and choose a name. You can activate and deactivate the checkbox by clicking on it. You can also change the text color, for example, to yellow. If you want to change the color of the checkbox in the checked state, use the foreground color parameter. Here I use, for example, orange. You can also change the hover color. Simply use the hover color parameter. Here I chose the color aqua, which is a light blue. When hovering over the checkbox, the hover color appears. You have also the opportunity to modify the corner radius of the checkbox. Setting the value of the corner radius parameter to 20 results in a round-shaped checkbox. Another property you can change is the border width. For example, you can use the border width parameter to increase the border of the checkbox. The border color is gray by default, but you can change its color as well. Just use the border color parameter. Here I change the border color to red. You can also define a command that will be executed when the checkbox is pressed. In this example, I will define a function that returns the state of the checkbox. The checkbox widget provides us with a get method, which gives us the current state of the checkbox, activated or deactivated. Our get_state function will print it out. After setting the checkbox into the main window, we can try it out. As you can see, when I press the checkbox, it gets activated and the number 1 is printed. When I press again, the status of the checkbox changes to disabled and a 0 is printed. If you want to change the values of the checkbox states, you can use the on value and off value parameters. Here I chose checked for the on value and unchecked for the off value. Now when I press the checkbox, the values checked and unchecked appear in the terminal. Entry. If you want to create an entry widget, just use the CTk Entry class. A simple entry field will appear in your application window. You can adjust the foreground color and also the text color to any color you want. It's also possible to modify the width and height of the entry widget. If you want to customize the shape, just use the corner radius parameter to get a round-shaped input field. It is also possible to add a placeholder text. The text color is white by default, but you can change it if necessary. Another property you can change is the border width. The border color can be changed as well. Here I chose crimson red. Sometimes you want to disable the entry widget because the entry field has no function in a certain situation. For this purpose, you can set the state to disabled. Now no input can be made in the entry widget. If you want to enable the entry widget again, you can do it by using the configure method and set the state back to normal. Then you can link the function to an event, for example, pressing a button. When the button is pressed, the entry widget gets clickable and you can make an input. ComboBox. A ComboBox widget can be created by using the CTk ComboBox class. You can define several options that can be selected from the drop-down menu of the ComboBox. To do this, simply use a list that contains all the options and provide them as parameter to the class object. As you can see, the drop-down displays all the options of the list, but you can also use the checkbox like an entry widget and enter your own value. There are a variety of properties available that can be customized. For example, you can change the foreground color and also the text color. If you want to change the color of the drop-down button, use the button color parameter. It is also possible to change the hover color of the button. Simply use the button hover color parameter. When hovering over the button color changes according to the given color. If you don't want the hover effect, you can disable it by setting the hover parameter to false. Then the color of the button will not change when you hover over it. You can also define a command that will be executed when one of the ComboBox options is pressed. For this purpose, simply use the command parameter and provide a function as value. Every time an option is pressed, the name of the option will automatically be provided to the function as input parameter. Therefore, you need to add an input parameter to your function. In this case, the function prints the name of the pressed option. Let's try it out. As you can see, when an option of the drop-down is pressed, the name of this option is printed in the terminal. You also have the option to change the border width. Simply use the border width parameter and provide a number as value. If desired, you can also change the border color. If you prefer a round-shaped ComboBox widget, you can modify the shape by using the corner radius parameter. Setting its value to 20 results in a round-shaped ComboBox. The drop-down list is customizable as well. For example, you can change the foreground color. The drop-down text color parameter allows you to change the text color in the drop-down list. If needed, the hover color of the drop-down can also be changed. Option menu. An option menu widget can be created by using the CTk OptionMenu class. Provide a list of options to the values parameter and you will get an option menu with a drop-down. As you can see, the option menu widget is quite similar to the ComboBox widget. The same parameters can be used to customize the widget. You can also add a function that will be executed if a value was chosen from the drop-down. As you can see, the function prints the name of the chosen option. The drop-down menu can also be customized in the same way as the ComboBox widget. The difference between the option menu widget and the ComboBox widget is that you cannot change the border width and border color of the option menu widget. In addition, entering a value is not possible. You can only select a value from the drop-down list. Segmented Button. Use the CTk SegmentedButton class to create a CheckBox widget. You have to provide a list of strings as parameter. The strings are used as names for the individual segments of the button. You can activate the segments by clicking on them. If you want to change the size of the button, you can use, for example, the height parameter. The color of the CheckBox widget can also be customized. Use the foreground color parameter to change the color behind the segments. The segments can be colored by using the unselected color parameter. If you want to change the color of the selected segment, just use the selected color parameter. In addition, the selected hover color parameter allows you also to modify the hover color of the selected segment. Changing the text color is also possible, just use the text color parameter. The border width is customizable as well. The border width parameter allows you to change the size of the border. You can link the segmented buttons to a function that will be executed when one of the buttons is pressed. For that purpose, first you need to define a function. In this example, I created a function that just prints out the name of the pressed segment. To link the function to the CheckBox widget, use the command parameter and provide the function name as value. As you can see, every time a segment of the segmented button is pressed, the value of the pressed segment is given as input to the function, and the function prints the value into the terminal. There is also the option to manipulate the widget interactively. For example, you can use the insert function to insert a new segment to the CheckBox widget. For this, the position and the name of the new segment must be given as parameters. Just for demonstration, I will use the insert function in our linked function of the widget. As you can see, when a segment is pressed, a new segment is inserted at the second position. Be aware that the new segment is also added to the segments list, and the position refers to the index of the list. Another function that can be used to manipulate the CheckBox widget is the delete function. It allows you to delete a segment of the widget. The segment that should be deleted must be provided as parameter. As you can see in this example, every time a segment is pressed, it is deleted. It is also possible to move a segment to another position. Use the move function for that. Two parameters must be given as input: the index of the new position and the name of the segment that will be moved. As you can see in this example, the clicked segment is always moved to the first position. If you want to modify the shape of the CheckBox widget, you can use the corner radius parameter. For example, a value of 20 results in a round-shaped segmented button. Slider. A slider widget can be created by using the CTk Slider class. The resulting slider widget contains a bar with a slider button. You can move the slider button along the bar. The slider widget can be linked to a function via the command parameter. Define a function and set the function name as value for the command parameter. As you can see, the current value of the slider widget is provided to the function every time the slider button is moved or pressed. The values have a range between 0 and 1, but you have the option to modify the value range. Use the parameters from _ and 2 to set a minimum value and a maximum value. In this example, I chose 0 as minimum and 100 as maximum value. As you can see in the terminal, the function prints now values between 0 and 100 when the slider is moved. You can also modify the number of steps. For example, if you set the number of steps parameter to 20, the value range is splitted to 20 equal parts. In the case of a value range from 0 to 100, the value changes in increments of 5 when the slider is moved. You have also the option to change the size of the slider. Use the width parameter to modify the slider width. And if you want to change the height of the slider, the height parameter is the way to go. The colors of the slider widget can be changed as well. For example, use the border color parameter to change the border color. In addition, the size of the border can be modified by using the border width parameter. It is also possible to change the colors of the bar. The foreground color parameter allows you to change the bar color to the right of the slider button. If you also want to modify the bar color to the left of the slider button, use the progress color parameter. The button color of the slider can be changed by using the button color parameter. As you have probably noticed, the slider button has a hover effect. Use the button hover color parameter if you want to change the hover color. As you can see, the color changes to the desired color while hovering over the slider button. If you don't like the hover effect, you can disable it. Just set the hover parameter to false. The color does not change anymore when hovering over the slider button. You have two options for the orientation of the slider widget. The default orientation is horizontal, but you can change it to vertical by using the orientation parameter. If it is necessary for your application, you can also deactivate the widget by setting the state parameter to disable. As you can see, the position of the slider button cannot be changed anymore. Switch. The switch widget is used to toggle the on-off state of a single setting. You can create a switch widget by using the CTk Switch class. The switch widget has a name which by default is CTk Switch, but you can change it. Simply use the text parameter and provide the desired name as string. As you can see, the text next to the switch widget changed to the given name. It is also possible to link the switch widget to a function. For this purpose, first create a function. In this example, I have defined a function that saves the state of the switch in a variable and then prints it out. In the next step, use the command parameter and provide the function name as value. As you can see, the state of the widget is printed in the terminal when the switch is toggled. A value of 1 indicates that the switch is on, 0 indicates that the switch is off. If you desire other values for the switch states, use the on value and off value parameters to change the values. For example, you can set the on value to on and the off value to off. Now the values on and off are printed in the terminal when the switch is toggled. The size of the switch widget can be modified as well. The switch width parameter allows you to change the width. For example, you can increase it. The height can also be changed. Use the switch height parameter for that. If you want to manipulate the shape, you can use the corner radius parameter. A value of 5 results in a rectangular-shaped widget. The switch widget has a border which can be modified as well. You can change the color by using the border color parameter. In addition, the border width parameter allows you to change the thickness of the border. There are also many options to customize the colors of the widget. For example, you can change the foreground color by using the foreground color parameter. This color only appears when the switch is in the off state. The progress color parameter allows you to change the color when the switch widget is in the on state. The button color of the switch can be changed as well. Just use the button color parameter and set a color of your choice. The button hover color parameter can be used to change the hover color of the button. The color appears when hovering over the button. As you have already seen in the previous widgets presented, you can deactivate the hover effect. If you set the hover parameter to false, the color does not change anymore when hovering over the switch button. You can also deactivate the entire widget. Set the state parameter to disabled and it is no longer possible to toggle the switch. Progress bar. A progress bar can be created by using the CTk ProgressBar class. Provide the main window as parameter and you will get a horizontal progress bar. You can customize the size of the progress bar. For example, you can increase the width of the bar. Just use the width parameter. You can change the height in the same way. Use the height parameter for this. The color can be also modified. With the foreground color parameter, you can change the color behind the bar. The color of the bar itself can be adjusted using the progress color parameter. If you want your progress bar to have a border, you can use the border width parameter. And the border color parameter allows you to change the border color. If you want a rectangular-shaped progress bar, you can set the corner radius parameter to 1. As you can see, the progress status is 0.5 by default, but you can set the value, for example, to 0. Just apply the set method to the progress bar class object. There are 2 modes for the progress animation. Firstly, there is the determinate mode for linear progress, which is the default mode. Secondly, you can use the indeterminate mode for unknown progress. We can start the progress animation by using the start method of the progress bar class objects. Now you can see what the 2 modes look like. In the determinate mode, the progress bar moves from left to right and then starts again from the left. In indeterminate mode, however, the progress bar moves back and forth between left and right. It is also possible to modify the movement speed of the progress bar. Simply use the determinate speed or the indeterminate speed parameter for this. A value above 1 increases the speed, while a value below 1 results in a slower speed. If you set the value to 0, the movement of the progress bar stops. You can also modify the orientation of the progress bar. If you set the value of the orientation parameter to vertical, you get a vertical arranged progress bar. Label. A label widget can be created by using the CTk Label class. You will get a label with CTk Label as default text, but you can change the label text simply by using the text parameter. The background is transparent, but you can give it a color if you want. The text color can be changed as well. If you want to change the size of the label, you can use the width and height parameters. You have also the option to change the shape of the label. For this, simply use the corner radius parameter. A value of 20 results in a round-shaped label. If you want to add an icon to your label, you need first to import image from PIL. Use the image.open function to open the image file and provide it to the CTk image class as parameter. Then use the image parameter of the label widget with the CTk image object as value. As you can see, the icon is placed in the center of the label and the text overlaps the icon. But you can adjust the position of the icon by using the compound parameter. Set the value to left and the icon will be placed on the left side of the label. In addition to the left, the icon can also be placed on the right side or on the top and on the bottom as well. By using the pad X and pad Y parameters, you can create a distance to the edge of the label. If you want a label with an icon but no text, use an empty string for the text parameter. This results in a label containing only the icon. Tabview. The CTk Tabview class allows you to create a Tabview widget. You can add new tabs with the add function. The tab name can be given as parameter. You can add as many tabs as you want. In this example, we add 3 tabs. As you can see, the tabs are CTk frames and can be used like CTk frames. You can place any widgets on them. For example, let's place a button widget on the first tab, a slider widget on the second tab, and a switch widget on the third tab. Now, a button widget appears on the first tab of the tab view. The second tab contains a slider widget and a switch widget is available on the third tab. There are many options to customize the widget. The width and the height parameters allow you to modify the size of the tab view frame. Another useful option is the corner radius parameter. You can use it to round off the corners. If you want to add a border, simply use the border width parameter. The color of the border can be changed by using the border color parameter. The frame color of the tab view widget can be changed as well. Use the foreground color parameter for that. Let's take a look at the segmented buttons of the tab view widget. If you want to modify the color behind the buttons, just use the segmented button foreground color parameter. The color of the selected tab button can be changed by using the segmented button selected color parameter. As you can see, the buttons have a hover effect. You can use the segmented button selected hover color parameter to modify the hover color of the selected button. The same can be done with the unselected buttons. The segmented button unselected color parameter allows you to change the color of the unselected buttons. Accordingly, the hover color can be changed with the segmented button unselected hover color parameter. It is also possible to change the text color of the button names. Just use the text color parameter. There is also the option to change the position of the segmented button. By default, the segmented buttons are located at the center top of the tab view frame. The anchor parameter allows you to adjust the position. The desired position can be given as value. For example, in W sets the segmented buttons at the top left. If you want the buttons at the top right, set the value to NE. The value SW places the buttons at the bottom left. Set the value to S if you want the buttons to be at the center bottom. And last but not least, the value SE puts the buttons at the bottom right. You have also the option to link the segmented buttons to a function. Just for demonstration, let's create a function that prints the name of the active tab. To do this, we use the get method, which returns us the name of the selected tab. Then we use the command parameter and set its value to the function name. As you can see, if we press the buttons, the names are printed in the terminal. Frame. Frames are used to organize and group widgets. Create a frame widget by using the CTk Frame class and provide the main window as parameter. An empty frame will be added to your main window. You have the option to change the foreground color to every color you like. A border can also be added using the border width parameter. If necessary, you can change the color of the frame border. Just use the border color parameter. You can place another frame next to the first frame, or in the next row of the grid. If you want to place the third frame in the middle under the other frames, you can use the column span parameter of the grid function. If you set the value to 2, both columns of the grid are combined and the frame is placed in the middle of the resulting 2-column wide row. You can modify the width of the frame so that it takes up the entire width of the window. The height of the frame can be modified as well. Frames can be used to group widgets. For example, you can place a few buttons in one of the frames. Instead of the main window, the frame needs to be provided as master parameter. In this example, we place the buttons in the first frame. You can easily change the arrangement of the frames, and any widgets placed in the frames will also be rearranged. For example, we can swap the 2 small frames, or we place the small frames under the large frame, and as you can see, the button widgets will always stay in the same frame. CrollableFrame. The CTk ScrollableFrame class allows you to create a frame that contains a scroll bar. Let's take a look at the customizable properties of this widget. If you want to change the width of the scrollable frame, you can use the width parameter. In the same way, the height can be changed with the height parameter. The corner radius parameter allows you to modify the shape of the scrollable frame. For example, a value of 30 results in round corners. You also have the option to add a border. To do this, use the border width parameter and specify a numeric value that determines the size of the border. The border is gray by default, but you can change the color by using the border color parameter. Another useful parameter is the foreground color. It can be used to change the color of the entire frame. It is also possible to modify the colors of the scrollbar. The scrollbar foreground color parameter allows you to change the border color of the scrollbar. In contrast, the inside of the scrollbar can be changed by using the scrollbar button color parameter. In the same way, you can use the scrollbar button hover color parameter if you want to change the hover color of the scrollbar. Another useful parameter is the label text. It creates a label on the top of the scrollable frame that contains the text you specified as value for the parameter. You can modify the font and the size of the text with the label font parameter. Just provide your desired font and text size as tuple. In addition, the label text color parameter can be used to change the text color. If you want to change the color of the entire label, use the label foreground color parameter. You can also modify the text position of the label. To do this, use the label anchor parameter and set it to a position of your choice. For example, setting the label anchor to W places the text on the left side, while setting the value for the label anchor to E places the text on the right side. Since the scrollable frame works like a frame widget, you can also place other widgets inside it. In this example, I place a button, a slider, and a switch in our scrollable frame. As you can see, the widgets are placed under each other and you can scroll down to the last widget. The orientation of the scrollbar is vertical by default, but you can modify it. Set the orientation parameter to horizontal, and the frame will be scrollable from left to right. Textbox. The Textbox widget allows users to enter multiple lines of text. You can create a textbox by using the CTk Textbox class. After initializing a textbox object and placing it into the main window, a text field appears. You can type any text. The size of the textbox can be modified. If you want to change the width, use the width parameter. In the same way, you can change the height of the text box using the height parameter. If you want to have a border, you can use the border width parameter and provide a numeric value. You will get a border which is gray by default, but the border color parameter allows you to change the color. You can also add a border space, which describes the distance between the border and the text. For this, use the border spacing parameter. You have also the option to modify the shape of the text box. The corner radius parameter can be used to round off the corners. If you want to change the color of the entire text box, use the foreground color parameter. The text color can also be changed. To do this, set the value of the text color parameter to a color of your choice. In addition, the font parameter allows you to adjust the font and the size of the text. The font and size must be given as a tuple. If your input text is larger than the text box, a scroll bar appears. You can change its color by using the scroll bar button color parameter. Since the scroll bar has a hover effect, it is also possible to change the hover color. Just use the scroll bar button hover color parameter. If you don't want to have a scroll bar in your text box, you can deactivate it by setting the Activate Scrollbars parameter to false. Now no scroll bar appears if the text length is larger than the text box. You can use the wrap parameter to influence how the text is split at the end of the line. The wrap parameter is set to char by default. This means that the text is split by character. If you want the text to be split by words, you need to set the wrap parameter to word. Another useful option is to set the wrap parameter to none. In this case, the text will not be splitted. Instead, a horizontal scroll bar appears and the text can be of any length. If it is necessary for your application to deactivate the text box, you can do that with the state parameter. Set it to disabled and it is no longer possible to enter any text. Scrollbar. The CTk Scrollbar widget allows you to add an external scrollbar to a text box. Therefore, a text box must first be created in order to use the scrollbar. Since the text box widget has its own scrollbar, we need to disable the scrollbar first. This can be easily done by setting the Activate Scrollbars parameter to false. What we get is a text box without a scrollbar. Now the scrollbar widget can be created from the CTk Scrollbar class. The scrollbar needs to be linked to the text box. To do this, we use the command parameter and set its value to the text box yView function. This function changes the view of the text box in Y direction. Furthermore, we have to connect the scroll event of the text box to the scrollbar. This can be done by using the configure method and setting the value of the YScroll command parameter to scrollbar.set method, which provides the position of the scrollbar slider. As you can see, we get a text box with a scrollbar. The scrollbar is on the right side because we set this position with the grid method. If you want to have the scrollbar on the left, you can achieve this by switching the values of the column indexes. Now the scrollbar appears on the left side. However, let's change it back to the right. There are many options to customize the look of the scroll bar. For example, you can change the width with the width parameter. The height can also be changed, just use the height parameter. For example, you can set the height to half the height of the text box. But in my opinion, this doesn't look nice, so I change it back to the exact height of the text box. You have various options to change the colors of the scroll bar. The foreground color parameter can be used to change the color around the slider of the scroll bar. The button color parameter allows you to change the color of the slider. If you want to change the color of the hover effect, use the button hover color parameter. In case you don't want a hover effect, you can use the hover parameter to disable it. Then the color will not change when hovering over the scroll bar. Another useful option is the corner radius parameter. It allows you to adjust the shape of the scroll bar. A value of 0 results in an angular-shaped scroll bar. The minimum size of the slider can be set with the minimum pixel length parameter. In this example, we set it to 50. This means that the size will shrink to a minimum of 50 pixels no matter how many lines are added within the text box. You have also the option to change the orientation of the scroll bar. It is vertical by default, but you can set it to horizontal by using the orientation parameter. We also need to adjust the values for the width and height. In addition, the value of the command parameter must be set to textbox.xView because the scrolling occurs in X direction. This also applies to the Y-scroll command parameter that needs to be replaced by the X-scroll command parameter. Since the scroll bar is horizontal now, it makes sense to place it under the text box. To do this, we adjust the parameters used in the grid method. In addition, we need to set the wrap parameter to none. This ensures that text can be written horizontally indefinitely without continuing to the next line once the edge of the line is reached. If you want to have the scroll bar above the text box, just swap the values of the row parameters in the grid methods of the text box and scroll bar. Color themes. If you are creating your GUI, you don't have to set all the color parameters one by one for every widget. That would be a very repetitive and time-consuming way to make the design for your application. Instead, you can use a JSON file like this to set the colors once for each widget. As you can see, this JSON file includes all widgets and their color parameters as well as border width and corner radius. In addition, you can also set the text font and size. In other words, here you can set your overall color theme, and the application can use this file to automatically adjust to that theme. All you need to do is to pass the path to your JSON file to the .setDefaultColor theme method. In this example, we pass the yellow.json file to the method. As you can see, our application has a yellow color theme now. The application uses the specified colors from the JSON file. If you don't want to create your own color theme, you can download various color themes from the internet. For example, you can find color themes for Customtkinter on GitHub. Link in the description. Just load the color theme to your application by passing the path to the JSON file, and you can quickly change between various themes. Try different color palettes and choose your favorite. Thanks for watching. If you want to see more coding content with Python, subscribe to the channel. See you in the next video.